Dr. Renat Widodo, STMT, received the doctoral degree Applied Geophysics in 2012 from Cologne University, Germany. Currently, he is working as a lecturer at Geophysical Engineering, Institut Teknologi Bandung. His research focused on geoelectric and electromagnetic method, application in mineral and oil exploration, geotechnical, agricultural geophysics, environmental problem, and innovation of geoelectric and electromagnetic method. And his latest project, handling the clean water crisis in Grabakan Subdistrict, Tuban region, East Java by utilizing geophysical technology and river stream flow, development of geoelectrical database groundwater exploration, prototype design for water resource security, application of upflow and geophysics method for groundwater exploration in answering the water crisis in the Bandung area, West Java. And his previous publication, 52 publication and 59 citation on research grade. Would you come, Mr. Widodo? Time is yours.
Okay, thank you very much. Wait a minute. Wait, I have some problem for the. Have you seen my presentation?
Yes, I can show it.
This is the full screen or only part of them?
The part of them, Mr.
Okay. Wait, and then which one? How about this one? Also similar?
Still similar, Mr.
What happened? I have a problem. Wait a minute. So, how about this? Also similar?
Still same, Mr.
Okay, wait. I think I got the problem with this. Okay, wait. Sorry for the technical issue, yes, because this is the new laptop. Therefore, I still have to know how to manage for this one, and then I will try again. I think this one is better, okay?
Yes, okay.
Sorry. Okay, good afternoon, everybody. So at the moment, I would like to share knowledge about geoelectromagnetics for engineering and environment. And this is for international virtual course, engineering and environment geophysics. And first of all, I would like to share about, wait, why? This one is my outline. Yes. Oh, wait a minute. I would like to show. Wait, I will show my. Okay. First, I would like to give presentation about the introduction, and then the second is about geoelectromagnetic and electromagnetic methods. And the third, also, I will give about the drawback, about the challenges and opportunities in GeoEM methods. And maybe I will show about the two cases. First case is about the engineering and geotechnic, and the second case about the environment in agriculture geophysics. And the last is about the conclusion. So why is GeoEM is very important in the, I think it's not only in the world, but also in Indonesia. First, I think we know about the GeoEM electromagnetic method is applicable for many subjects. Maybe it's not only in mineral exploration, but also in contaminants, water, geothermal, and then also maybe in geotechnics, and some of application also for the slope stability, and few of them for hydrocarbon. Maybe all audience already knows about the marine EM, and then this for exploration hydrocarbon in offshore, and also for environmental case study. This one is very important because almost of this method is non-invasive methods. That means we don't need about the blasting, and also this is very green environment methods. And third, this method is also very useful for the shallow penetration depth and until a deeper part for investigation. And this is about the brief explanation about the GeoEM method. I think all of them is already knew about this method. First, for the geoelectric method, they consist of resistivity method. Yes, we use direct current source, and the second about the induced polarization method, and this method is very useful for coal exploration due to we can record about the touchability for the metal. And the last, I think, is not familiar in here, but this one is also is very important about the self potential method, and this method is very useful for measured about the natural potential in the earth. And for electromagnetic method, they divided to somehow they divided in the two domain. First about the frequency domain, and then second is maybe about the time domain. But for the some of people, they also divided versus about the propagation wave, an example GPR, yes, and the second is induction wave, an example time domain EM. So this one is the brief explanation for this method, and this method also can cover for shallow penetration depth until the deeper part in exploration. So, and this is only about the few difference between direct current and electromagnetic methods. In the electromagnetic method, somehow for the active method, the current is injected by galvanic contacts. Yes, something this one is for the electric method, and with the direct current or very low frequency source of current. Therefore, for the time domain EM, yes, the current is induced in the ground by using source and alternating current. This one is for direct current, and the second one is in EM is alternating current. And how about for the depth of investigation? The depth of investigation for EM method is associated with the geometry of electrode layouts, maybe the maximum spacing between the electrodes. Otherwise, for the EM method, the source field, they correspond to the time or frequency domain have deployed in the earth. Okay, this is the general rules of thumb of resistivity. I think this is very important for us, yes, because we somehow explore from the igneous rock until sedimentary rock, but this one is the rule of thumb. If the igneous rock is very high resistivity, then a more metamorphic rock on the sedimentary rock, and also vice versa. For the sedimentary rock is somehow is very conductive then compared with the igneous rock and metamorphic rock. This one is due to about the porosity and also about the permeability in this inside in this rock. And then seconds, how about the Alder and the Zhang's rocks? The Zhang rocks, somehow the Alder rocks, somehow is very high resistivity because more time to fill in fracture and pore space. Therefore, for the high resistivity in Alder rock, somehow is associated with the metamorphic rock and also with the igneous rock. And for the younger rock, somehow is very lower resistivity or maybe is more conductive because abundant of fracture and also for space inside in the rocks. So for this one, I think we have opportunity and also challenges in GeoEM method. Why? First, as I mentioned earlier, this method is can spread. It's not only in the shallow but also in the deeper part. And the second, this method is an invasive method. And the third, this method also can map in anomaly of resistivity or maybe a conductivity inside in the rock. And I think we already know about in Indonesia. I think Indonesia is the most beautiful country. Why? Because in Indonesia, for application geophysics, they have so many subjects. It's not only about the natural resources, somehow for exploration in the coal exploration, and also in Indonesia, they have a geological aspect. Yes, an example, fault structure, landslide, and so on. Yes, and at the moment, also in Indonesia, they already made many infrastructure, yes, some was like high-speed railway, but however, Indonesia so have many hazards, maybe flooding and also landslide and so on. Yes. Therefore, this one is the opportunity for us to apply the GEM methods. So, and as I mentioned, yeah, is this emphasis on the geological, hydrogeological, maybe in mineral, and also in the environmental and engineering, and somehow for the hazard mitigation. This one need to be know about the physical properties of the subsurface. Yes, because somehow the GEM method can use for the early warning. Yes, early warning to know about the physical property of the subsurface, as mentioned for the hazard mitigation in this area. And the other challenges, I think it is well known that Indonesia is agrarian country, and then somehow we need to know about the precision farming in the agriculture. And I think this is very seldom to apply in Indonesia about the geophysics. Yes, because in geophysics we can I think it's better we know about the subsurface structure, and we also, this one is very important for the precision of agriculture. Yes, agriculture geophysics. Yes, because and then we can use maybe EM38 or also with the DC resistivity to cover or to know about the precision farming in the agriculture. Maybe in the next, I will give some short explanation about the agriculture geophysics. Okay, yes. And then how about the next challenges for us? Yes, I think this already, I have many information from my college in Europe. Yes, they offer a PhD position. Yes, especially for modeling and also to make own software. Yes, and I think this is the opportunity for us. Yes, we can maybe develop many software in here in Indonesia, especially, and especially for 3D software and also 2D software. I think it's better for us, and then we can I think we will leading in the we will lead in GEM application if we can create some software with ourselves. An example maybe for the DC resistivity, also for electromagnetic method. Yes. And as I mentioned before, I would like to explain about the first case is about the combination about the geoelectric and geotechnic investigation. Yes, to evaluate the slope stability subjects, yeah, to blasting variation in the case study about the Jakarta-Bandung high-speed railway tunnel. Yes, and this one is very important also in Indonesia for the infrastructure. And this research already done with my student Hermawan, and it's not only in tunnel 11, also with the some tunnel, and with my college Mr. Simon for mining engineering. Yes. And this one is why this one is very important, because the set location is located in the Pohong Mount, Padalarang, and this area with the hilly area with the slopes approximate 30 degrees. And this area also have a potential landslide, and we can see in the right slide in here, they have some crack in the housing residential is near in this area due to ground motion surrounding in this area. and we need to know about the subsurface information according to make entrance of tunnel, yes, from the speed highway Jakarta Bandung. Therefore, we apply in here with the fast vertical electrical sounding and also with the electrical resistivity sounding. We have done with the 4 lines ERT, electrical resistivity tomography, and some parts in the 4 sounding of vertical electrical sounding, and this one is also correlated with the borehole data for the phase 1 and also for the phase 2, which correlated with the borehole data number 4 and borehole data number 1. And the table 1, we can see about the geometric parameter. We have used dipole configuration for ERT, and the depth of investigation is around 50 meters depth. Yeah. And for the second part, we already done also with the geotechnical investigation. This my colleagues from mining engineering, they made SPT, yes, and then they correlate the SPT for with the borehole data, and then we can see in here the top layer is associated with the siltous clay, and then the basement of the area is correspondent to the andesite apraxia. And table 2 is the detailed information about the SPT data, yes, and the SPT data, they made a laboratory test in the mining exploration, in the mining engineering in ITB, and they already made upon the book modulus yang and so on. And as I mentioned before, I already we made some software for inversion. Yes, we have already done with the least square method software, and this one is for the 1D data processing in resistivity methods. Yes, we use Jacobian metric in here just to make a linearization of the nonlinear equation. Yes, and then we the better one, we also have some borehole data. Therefore, for the modeling, I think it's not so difficult. Yes. And to make sure our software, we already test with the compare with the IP twins. Yes, and then this one is the IP twin results. Yes, they have, and this one is our software. We use we call our the software is Resep Banyu. Yeah, there's already we have done some processing with the 1D data, and for the comparison, it looks quite matching between IP twin and Resep Banyu software. Yeah, and then we for the phase 1 and also for the phase 2. Yes. And the fitting data also is very good between offset and calculate data. Therefore, the RMS error is less than 2%. Yeah, this quite good results. Yeah, for the IP twin, we have 6 and 4%, but for our software, we already produce around 2%. Yes, for the RMS error. Due to the fitting between offset and calculate, they like quite good result. Okay, and the other techniques, as I mentioned before, if we have some borehole data, and we also correlate the borehole data to our first model, yes, and the borehole data looks quite good fitting, yes, or maybe the features is quite a similar feature between the borehole data and then with the first model, yes. The first is correspond to the silty, yeah, and then the second is the conductive. This one is conductive part, and this is more conductive, and the last is also corresponded with the brexy in the as bedrock in this study area. And the borehole data, they have a good feature with the first one and also for the first two. Yeah, this means the software produce is give good models for the 1D first data. So the next, we already done with the 2D model of ERT data, and also for the interpretation we have done, we correlate the borehole inside in the ERT data and the resistive part as associated with the andesite brexy, and the conductive part, the this correspond to the silty clay, and then the medium part is, I think, is around 64 ohmmeter. This corresponding with the gravelly clay. Yes, they have three material in this area. First is the resistive part is associated with the andesite brexy, and then the conductive part is corresponding to silty clay. And this one is for the line IE accent, yes, and then the second is P and P accent. This ones, the second ones, and also they produce three layers in this area, and we have done also with the correlate with the borehole data pH 1, yes, and quite looks well about the silty clay. They around about the 1632 ohmmeter, and for the gravelly clay they already around 32 ohmmeter also, and the resistive part, they have a resistivity value more than 30 ohmmeter. And how about the for the line C and C accent? Yes, they is perpendicular to the line A and E accent and P accent. Yes, they have three borehole data in this area, and then they have a match also in the borehole data, and the resistive part correspond to the brexy in this area. And the last, we also made correlation between the line T and T accent with the, but unfortunately we don't have any borehole data in this area. But for the three lines earlier, we can we have already the borehole data, and then we can interpret it about the geological part in this area. Okay, and just to make sure, yes, we have done with the Huasi 3D model. That means we make some correlation for the all 2D model, yes, in here. And then if we can see in here, they have a good fitting between each other, yes. The cross section of the 2D model, they also have the same feature, yes, and that means this supported each other for this each model, yes. So next, we already done also found the correlation between the resistivity and SPT data. Yes, from the resistivity and SPT data, we don't have any correlation, but we can see in here they have some features between the SPT and resistivity data. It looks like from the pH, maybe borehole data number 1, looks like they have a constant between resistivity data and also with the SPT data. And the blue one is correspond to the SPT data, and the yellow one is correspond to the resistivity data. But some scientists, yes, they already mentioned if they know correlation between SPT and resistivity data. So just to know about the slope stability analysis in this area, we already made some geotechnical analysis also, and I think the potential landslide is supposed to be boundary of the gravelly clay and also with the silty clay. Therefore, this area is still have managed to occur upon the landslide, and also from the borehole, the line P and P accent, they already made some analysis on the slope stability, and luckily we already done with the blasting in this area, and then we don't have any accident or maybe any landslide in this area. So we can conclude that the integration of the electrical resistivity and geotechnics allow us to develop, yes, the geotechnic model and the subsurface with the less ambiguity, yes, because this is very important for the geophysical survey, and also geophysical survey somehow is not so expensive, yes, like in geotechnic survey. And then second one, the result of the study, yes, we can combine about the geoelectric and geotechnic method could help, yes, condition and its complexity, which play a vital role in the assessing to the stability of slope, particularly the slope that's subject dynamic loading from the tunnel blast of the high-speed railway. Yes, so sorry, we already still have a time, Mr. Wahyudi. Hello.
Yes, sir.
Yes.
Until 5:50.
So okay. So good. Okay, I will next go to the agriculture geophysics. Yes, for the second case in here, and I think agricultural geophysics is very important in Indonesia. Yes, because why? Yes, this is according with the precision farming in Indonesia. Yes, I think all of the agriculture agriculture land they haven't used geophysical method, yeah, to know about the subsurface of the physical properties due to about the precision farming in this area. And therefore the agriculture geophysics is very important in here. And the second one, the non-invasive geophysical techniques for to know about the soil subsurface in this area. Yeah, that's mean, of course, if we maybe in Europe they have a very large agriculture land, but Indonesia, the challenges in Indonesia, they only have a small, yes, maybe in Europe they more than 1 hectare, or maybe in Indonesia is maybe only few 100 meters. Yeah, this is the problem. So this is some research from the earlier scientists, yes, from Hagri. They use geophysical resistivity method to know about the roots, yes, root of the tree inside, and somehow the roots is associated with the high resistivity, and if no root, they could be some conductive part in this area. And the second one, also for Schmidt-Helter, they correlated with the EM30X, or for the electromagnetic methods, yes, for the spatial soil analysis, yeah, and they also correlate with the Krupp gel, yeah, per years, and they have a good correlation between soil analysis also with the Krupp gels in this area. So we already have done also the agriculture geophysics, and this already done with my student Wulan, yes. And the study area is located in Parompong, Lembang, Bandung, West Java. Yeah, it's not so far from ITB. I think it's around 20 minutes. Yes, we made we applied two methods in here. First is the resistivity method, yes, and the second with the EM30X, yes, inductive EM30X, and then we already have the equipment in our library in ITB, and for the resistivity method also. So we have done with the 10 line in this area, but and then we carry out with using ABEM device, not ABEM device. This one is sorry, I can remember this name of the equipment. But as mentioned in here is the same line between EM38 and the resistivity method in this area. Yes, it is very advantage for us, and then we can compare directly between the resistivity model and also with the conductivity model in this area. So this one we have done with the EM30X, and they have two coil in here. First coil is sprayed with the 0.5, and then another one is 1 meter space coil in here. And then for the 1 meter is the depth of investigation, I think is around 2 meter depths, and then for the 0.5 is I think it's only around maybe 1 meter depth. Yeah, it's very shallow, but sure, this one is only for the agriculture, and this is also for important for agriculture, correlate with the precision farming in this area. So for make sure to better interpretation, and we already done also with the test bit data. The test bit data is around almost 1 meter depth, and the other is around 90 centimeter. Yes, we just compare with the test bit data and also with the geophysical model for the later interpretation. Here we have done with the Weiner and dipole-dipole configuration, and then the Weiner and dipole-dipole configuration, they show very less RMS error, and then we only use, I think it's around half meter spacing. Yes, therefore the depth of investigation is around 4 meter depths, yeah, for the dipole-dipole, and for the Weiner is around also is 3.9 depths. Yes, but looks like in the models, 2D model is the same feature between Weiner and dipole-dipole configuration, and there is have good data between Weiner and dipole-dipole configuration. I think this is a good chance to know about the soil physical properties of the soil in this area. And for the conductivity model, yes, the red one is correspond to the coil space of 0.5 meter. Sorry, for the conductivity of coil space of 1 meter, but the green one is correspond to the conductivity of coil space 0.5 meter, and the conductive space of 0.5 meter is associated with the shallow penetration depth, and it looks like for the shallow penetration depth they have quite more resistive than the 0 meter coil space. Yes. Also for the line X, yes, the green one is more resistive than the red ones. Yes, this is the conductivity. And for just to make the fitting between a 2D model, also we already done with the quasi 3D models in here, or for the Weiner and dipole configuration. So it looks like they have same features between Weiner and dipole configuration, and also the shallow depth corresponding to the high resistivity, yes, but the deeper part is associated with the conductive part. This is almost similar with the EM38 data, yes, model, yeah. And this one is EM38 model, as the top layer is more resistive than the deeper part. Yes, and also if we back to the resistivity model, and the subsurface is more resistive also with the deeper part. So they have a good correlation between EM38 and also with the geoelectric models in this area. So we can conclude in here, if the GeoEM, yes, they have give a good results in order to know about the shallow physical properties. And in the second ones, the geoelectric data on the model, yeah, the value of the resistivity between 15 until 150, 170, while the distribution of the conductivity value, yes, obtained from the EM38 is around 2 until 4 millisiemens per meter, and for the depth of 0.75 meter, yes, depth is only for the coil of 0.5 space coil. And the second and the third, they are mutually supported data between geophysical model and test speed data model, and the models in order to support resistivity and conductivity data, yeah, upon the fertility value, it is better if we spot with the temperature, salinity, soil, maybe, yes, chemical content, humidity level, and others. Yeah, therefore I think this is the last my presentation, and we can one opportunity we can develop our knowledge in geophysics, especially in GeoEM, to apply several subjects. Yeah, maybe it's not only for the mineral exploration, but also for agriculture geophysics. Yeah, for the agricultural subject. So we have a last, and I would like to invite all of you, yes, because we have next event for international virtual course will be held on the 18th October until 2 November 2021. Yes, you can, if you would like to register, you can contact Farhan maybe, and then also Dian and Rizka. And this virtual course also keep not only from scientists from Indonesia, they also from the foreign country, an example from Mr. Martin Answorth, yes, is from the Alberta University of Canada, and then Professor Nikolai is from Russia, and then Professor Ute Wigman is also from Potsdam, Germany, and then my colleague from India, Dr. Sudha, and some my colleagues from Indonesia. They also have Mr. Wahyudi, Mr. Simon, and then Mr. Warsa also, and Mr. Fatkan, yes. And then some of my colleagues from metallurgy, yes. This Dr. Imam, and also Dr. Asef from geology, and the other one is Dr. Sylvie from petroleum engineering. And also, I think the keynote speaker is Mr. Joko, and hopefully my professor from Cologne is Professor Pulunteskan can also give a talk in the seminar. Yes. So don't forget to register for the seminar. I'm sorry, Mr. Wayudi. I also give some invitation for the next IVC. Yes. Yeah. Thank you very much for your attention. If you have any discussion or maybe some information for IVC, please just ask me. Thank you.
Thank you for Mr. Widodo. This topic is really interested. For me, actually, agricultural geophysics. And for all the participants who want to ask Mr. Widodo, please write your question on a chat box or raise your hand and directly say your question to Mr. Widodo.
Okay, and I already have a question from Ramadhani. Yes. Oh, wait a minute. It's from Ramadhani. Yeah. From Ramadhani. Yes. As mentioned in your presentation, in case 1, dipole configuration was used for the resistivity survey. Right? Why this configuration is used? Is dipole good for profiling or sounding? Yes. Can you explain advantage of the each configuration? Thank you. Yeah. So maybe use dipole. Yeah. I will show you. Wait a minute. I will back to the. Where is my presentation now? Okay. So this one, yes. So as information, we are not only use for the dipole in this area, we also use a winner. Yes, if yeah, here, yeah. So the depth of the tunnel entrance in here, I think, is around more than 40 meters, yes, depth from the hill, yeah, in here. Therefore, I use a table in here. Choosing the table is good in the deeper parts investigation. So I think this is not about the sounding or profiling in table. I think we have 3 methods for the geoelectric measurement. First is for the soundings, second about the mapping, and the third is some people they call combined sounding and mapping, or they call also some people they call profiling. So I think for the 2D, I think it's you will catch. It's not only in the the Z direction, but you also have the horizontal direction. It's not only the vertical, but you also have a horizontal direction. Yes. Even for the 1D, maybe you only have vertical information. Yeah. Therefore, in here we use dipole table to do the deeper part. For the we need to know about the subsurface until 50-meter depth. Yes, in this area. And then I think the dipole table is good in the deeper structure than the other methods. Okay. It's only once.
Okay, any question for other participant? Please fill in chat box or raise your hand to deliver directly.
See anything in here? Stop. So you can see in here. Okay.
Okay, Mr. Widodo, there's one question again from Rizka.
Which one?
How is the quasi 3D?
It's the quasi 3D processing method on the EM38 data. Yes. So, be honest, yes, in EM30X data, we need to invert this data, yeah. But somehow, until now, we don't have any software to invert EM38 data, yes. And then my students, they only use, they only plot in the server software, and then we just combine from the quasi 3D, and then they made in the server software. Yeah, but I think it's if you would like to do this one, and then it's my opinion, you need to do first the inversion of magnetic field in this data, also in the electric field, and then after that you can maybe makes but the data is only something like mapping, yes, in EM30X, yes. But if you need to do the 3D data, you must have not only one or two lines, you must have also with the perpendicular lines, yeah, just to give a good model in this data. So this kind of thing is better if you are done with the invert. You need to invert this data. It's not only just to plot the data, but I think it's better if you just need to invert the data. And there are many publications about this one. You can read this one. So it's already very tired, yes, from the morning until now. Also, Mr. Wahyudi, I think. Therefore, I just make quickly. From the river, Mr. Widodo, can we collaborate Geoelectric method with the microthermal method for agriculture? Yeah. I think it's not only for GeoEM method is can use in the agriculture. I mean this one, yes. You need the innovation, yeah. Maybe it's not only for the such of method, and then I am very sure it's not only leading one or two method in geophysics, yeah, they have also advantage and disadvantage for the each method, yes. If you want to collaborate between geoelectric method and microthermal method, I think it's better also, yes. But this is, I think, this is chance for us just to make some research and also publication, yeah. Maybe this one is we just thinking about in offshore, yes, maybe also is very useful for us. And then we know, I think there are many application in the water, yeah. And also you can innovate this method to apply in exploration in the water, somehow like marine EM, yeah, somehow like fluid TDM, yeah. Maybe I will give a talk for the next IVC about the fluid TEM, yeah. This is also very important for us, especially for hazard mitigation, yeah, according with the flooding area, yeah. Yes, good question from the Colin, yeah. ERT standard arise, resolution decrease rapidly with the depth, yeah. How some uses RG law to validate the ERT model, yeah. First, yeah, we must know about the fundamental of electricity ERT, yeah, electrical resistivity methods. And then in the shallow part, yeah, if we have subsurface conductive surface, the current will be flowing everywhere, yeah. But in the deeper part, of course, if you want to have a good penetration depth, you not only use the large spacing, but you must consider about the how much current you can inject in the ground, yeah. This is very important in Indonesia. Somehow Indonesia, they use maybe vertical electrical sounding until 1 kilometer length, and then but they only use battery, yeah, maybe 12 volt. This is useless, yeah. Therefore, I think it's better you must consider about how much current you can inject in the car in the ground, yes. And then of course in the shallow part they have a good they have a good connection, but in the deeper part this rapidly dawn upon the current, yeah. And this is also you can learn about how to calculate about the DOE, yeah, with the sensitivity model, yeah. Somehow the sensitivity model leads not directly to the deeper part. And if we have done maybe with the Resistivity model, yes, somehow something like ships, but this is not so correct 100%, yeah. We need to know about the sensitivity model also, just to know about the how deeps of the current can goes down in the ground, yeah. And then the second, how about the RG law to validate the ERT model? You must consider the RG law is only correspond to the sedimentary rocks, yes, not for the all rocks, yeah. Therefore, RG law is somehow is if your area may be associated with the sedimentary rock, sure you must consider about the RG law. But maybe it's not only your area is correspond to maybe the igneous rock or metamorphic rock. I think it's not correspond to the RG law. Okay, which more powerful geoelectric informed study? This depends, yes. This you cannot say this one is very powerful and this one is less powerful, yes. This is depends of the subject of your I mean your exploration subject, yeah. Sure, for EM this is very good for the exploration in the conductive subject, somehow like mineral, yeah, mineral, metal, water, groundwater, and so on. But But in DC also, they have a good correlation also in the, if you have maybe anomaly in the resistivity value, I think it's better also you can use DC, yeah. But DC, I think, is more easy than it's not so difficult to make processing data than EM data. Yeah, EM is more complicated, yeah, to process. But sure, I think is if you learn, I think it's not so difficult. Yeah. Okay. From Alwan, may I ask whether the theory EM can be applied to geothermal exploration? If possible, for what purpose? Yeah. So some people, yeah, at the moment, maybe in the next IVC, and they have some explanation for the geothermal exploration, but I will tell something like that. Yes, in geothermal, you have reservoir, and also you have a clay cap. Yes, this one is very important. And I think it's better if you use put method, yeah, and they call maybe a joint inversion between, maybe you can use a DC method, and you can also use a time domain EM method. Yes, for the DC method, yeah, they can they have a good in the shallow part penetration depth, yeah, from the time domain EM, they have a good from the deeper part. But from the reservoir, people, they use magnetotelluric method. So if you can, I think this one is one topic also for PhD or maybe for the thesis, yes, you can, the subject is upon the joint inversion, yeah. The joint inversion is not a joint interpretation. This one is the joint inversion. That means you put all together, yes, your data, DC, TDM, MT in one algorithm, in one process inversion, yeah, and then you will catch a very good correlation, yeah, from the subsurface in the shallow depth until the deeper part, and then they can resolve about the until from the subsurface until the deeper part in the reservoir, yeah, structure. I think this is also very good for us if you just combine not only one method, but you also made maybe join several methods. Yeah. So from Pandu, the explanation about the slope stability analysis, you said that there was no accident during the blasting test. What if the earthquake occurs? Does the results of the slope stability analysis also apply to this? They know it's not too far from the Lembang Fault. Yeah, I think it's the big issue. This already mentioned also in TV1. Yes, my colleague, Mr. Simon, also give explanation in TV1. So the cracks inside the housing resident surrounding in this area, this is not because the blasting process, but this one correspond to the land movement in this area. Why I can say something like that? Because we already done also with the GPR investigation in this area, and they have not correlate with the blasting in this area. Therefore, they don't have any impacts yet. Maybe it's only small impacts to correspond to the resistant people surrounding in this area. So yes, this is the big issue. Also, a big due to the people surrounding in the area, they would like to move to another village, yeah, or to another residential small with the good wealth, and also with the good house and also with the new infrastructure. But this one I think is still going on the process. Yeah, but sure we not question the political issue inside in this research. Okay, this one's all my explanation. They have also any question? I think it's already tired.
Maybe that's last question, Mr. Widodo.
Yeah, okay, thank you very much. Yes, for your attention. I hope you all of them can join also in the last IVC, yeah, maybe in the GEM and applied science and also with the technology. Okay, thank you. Thank you very much, Mr. Wayudi, for inviting me to give a talk. It was very,
You're welcome.
Yeah, good discussion with our participant in here.
Good.
Okay, thank you very much for Mr. Widodo for your attendance, for your presentation, and for your answer our question. Maybe we have a photo session. Can everyone, all participants, open the camera? So I will taking a picture for us from the screen. Mr. Widodo, can you please open your camera? Thank you, Mr. Widodo. Okay, the first page, I will take a picture. And then the second page. And then third page. Fourth page. And the last page. Okay, thank you for everyone. And Mr. Widodo, if you have anything to do again after this event, you can do it and leave the.
Okay. Sorry, I want so one information. Yes, on my APC. My APC is not only international virtual course of ITB, but this is also joint webinar on international online near surface in Hagi. Yeah, they have a joint conference between Hagi and ITB. Yeah, I hope you can participate. Yes, in the middle of October until the earlier of November. Yeah, and then so I hope all of us is keep safe and healthy. Thank you very much. Yeah.
Thank you very much, Mr. Widodo. Thank you for attendance.
Yeah.
See you on your IVC.
Okay, thank you.
And for all participants, now is a quiz session. For Mbak Rama, could you share the link of the quiz? Quiz will be held for 15 minutes. And you can check link on a chat box and you can fill it for 15 minutes. Pak Yudi,
yes.
We close the.
May I leave this meeting?
Or,
Mr.
never mind, Pak Widodo.
Yes.
Mr. Widodo.
You
Okay,
can leave this meeting if you want.
Yeah. See you tomorrow.
See you tomorrow. Yeah.
Okay, thank you very much.
Yeah.
Thank you very much.
Okay, assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
warahmatullahi wabarakatuh.
Okay, we can end this session maybe in 10 minutes. I think we can wait for it. Yeah.
Okay.
Yeah.
We will wait for your quiz here.
Yeah. Yeah.
You
Until
can
the
check
quiz.
the link on the chat box to fill the Google form and the quiz.
Yeah, and tomorrow we will meet again at 13 o'clock. What is the topic, Rifa?
For tomorrow?
For tomorrow, yeah.
At 1 p.m.
Yeah.
From Atsushi Higuchi, Professor Atsushi Higuchi.
Mm-hmm.
The topic is meteorological satellite for weather observation.
Okay.
And
in the evening?
Yes, and in the evening from Professor Budi Sulistyo, the topic is applied geophysics for environment. Okay, yeah. Okay. So beginning from today, we have 2 sessions every day. Yeah. It's from 1 to 3 o'clock, and then in the evening from 7 to 9 o'clock p.m. Okay, we still have time, yeah, around 13 minutes. Okay, for all participants, please fill quiz and check the link on the chat box and fill the link to attendance this meeting and on the right topic. Okay. Okay, to all participants, thank you for your attendance and your attention for the second session of today. I will inform you to fill the quiz session and the link on the chat box. It will be held until 8:30 p.m. So maybe this session is over. Thank you for your attention and attendance. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for all. Okay, now I close the meeting. Thank you for all attendance. Okay.